All right, so I want to talk about the cookie jar problem. By the way, I'm not always going to go over every single homework question that you have, uh, from the previous day's homework. But but this is a really good problem, and I wanted to talk about it with you real quick. Students come up with all kinds of ways to solve this problem, and I want to talk about a few of them with you. So let's read through the problem, okay? So it says, there was a jar of cookies on the table. Becky was hungry because she hadn't had breakfast, so she ate half the cookies. Then Jill came along and noticed the cookies. She thought they looked good, so she ate a third of what was left in the jar. Denise came by and decided to take a fourth of the remaining cookies with her to her next class. Then Jody came dashing up and took a cookie to munch on. When Megan looked at the cookie jar, she saw that there were 2 cookies left. How many cookies were there in the jar to begin with? So first of all, let me just say, I don't know how you eat. Like, for me, I mean, I love cookies, don't get me wrong, but like on an empty stomach, if you're hungry to eat a cookie as a snack, like, ugh, that gives me heartburn. Like, I can eat spicy foods all day long, it's fine. But like, if I eat sugar on an empty stomach, I get heartburn. Anyway, but we'll just go for it. So they're all having breakfast of champion, I guess. The breakfast of champions cookies. Or I guess only Becky is the one who ate it for breakfast. The rest of them just were maybe having them as snacks throughout the day. But okay, so let's talk about this cookie jar problem. Now, the correct answer to this question is 12. There are 12 cookies in the jar to begin with. Some common wrong answers are 24. So a lot of times people will say the answer is 24. And then another common wrong answer is 72. And so I'll talk about how people end up with those answers a little bit. So as for 24, a lot of times people end up with the answer of 24 because they see fractions in the problem and they automatically think to themselves, common denominator, right? So they see that someone came along and took half of the cookies, and then someone else came along and took a third of what was left, and then someone else came along and took a fourth of what was left, and they're like, so I can get a common denominator. How do I get a common denominator? Well, I multiply all of the denominators together, and 2 times 3 is 6, and 6 times 4 is 24. So there must have been 24 cookies to begin with. 2 problems with this. First of all, it's just a straight up guess, right? It's like there's no reasoning here. You just saw fractions and you thought to yourself, common denominator. But there's no reason for a common denominator. You don't necessarily have to have a common denominator. Maybe your thought process is something like, well, but the number of cookies has to be divisible by 2, 3, and 4 since somebody's coming along taking half and then third and then fourths. And that's true, I guess, but that doesn't necessarily mean that you need 24 of them, because notice 48 would also work. 2, 3, and 4 all go into 48. 12 would also work, and that's the second big issue with this, is that 24 is not the least common denominator. It is a common denominator for these fractions, but it's not the least common denominator, right? The least common denominator would be 12. 2 goes into 12, 3 goes into 12, 4 goes into 12. So if you're getting 24 because you're thinking, common denominator here, it's like, in the first place, there's really nothing that ties this problem to common denominators directly. I mean, it was a very shallow thought process. So you need to dig a little deeper next time if this was your reasoning. So first of all, it was just shallow thinking, which isn't good in a math class. You need to think deeply about these problems. Maybe not too deeply. We don't want to get like philosophical, okay? but yeah, you need to think a little bit harder about it. And then the second problem is, of course, that 24 is not the least common denominator. And it's not the only possible common denominator. There are infinitely many common denominators. So you would have to do a little bit more work to sort of verify whether or not 24 actually works. So that takes care of 24. 72, the reason that people get 72 is a little bit trickier, and so I'll talk about that as we go through solving the problem. So let's talk about maybe some correct ways to do the problem. Okay, so let's talk about some correct ways to solve this problem. One thing that you could do is you could draw a picture. So here's solution 1. So draw a picture. And the exact picture that you draw may look a lot different than the picture that I'm about to draw. That's okay. But here's one way to draw the picture. You could say, okay, so this circle here is going to represent the original cookie jar. Okay? There's some number of cookies inside of here that we don't know yet. But what we do know is that it says Becky was hungry because she hadn't had breakfast, so she ate half of the cookies. So I'm going to draw a line about halfway through this jar and say Becky ate this half. Becky must have been really hungry. Okay, but Becky ate all of those cookies up there. Then what happens? Well, it says, then Jill came along and noticed the cookies. She thought they looked good, so she ate a third of what was left in the jar. Now be careful. It doesn't say that she ate a third of the cookies. It said she ate a third of what was left. So if you think about this bottom half of the jar, this is the cookies that are left, and Jill came along and ate a third of those. So we need to split this into 3 equal-ish parts. I'm trying to draw them as equal as I can. Okay, so this is what Jill ate. She ate, that third of what was left. Okay, then it says Denise came by and decided to take a fourth of the remaining cookies with her to her next class. So these are the remaining cookies, and Denise wants to take a fourth of them. So notice that these two parts should be approximately the same size, right? So in order to get a fourth, I could split each of them in half. Now I've got 1, 2, 3, 4 equal parts. Denise takes 1/4 of those. Okay, so Denise takes this much. Okay. Then it says, then Jody came dashing up and took a cookie to munch on. So Jody ate 1 cookie. Now, we don't know that this slice represents 1 cookie. Maybe it represents 3 cookies or 5 cookies, right? So we can't really label like what Jody took, I guess, until we read what Megan notices, right? So the last sort of key says, when Megan looked at the jar, she saw that there were 2 cookies left. So there were 2 cookies left after Jody took her 1 cookie. So that means that after Denise took her cookies, there should have been 3 cookies in the jar. So sure enough, this one slice is what Jody took. So, and that represents 1 cookie, right? That's 1 cookie. So each of these littlest slices are worth 1 cookie. And so then the question is, how many of these little slices would we need in order to completely split this figure up into equal parts? So notice that to get these little slices, I split these into thirds, and then I split the thirds in half. So if I do that to the top as well, split it into thirds, and then split the thirds in half. Now, how many slices do I have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 cookies. Okay, so 12 cookies. So that's one way that you could do it. You could do it by drawing a picture. Another way you could do it would be guess and check. So guess and check is literally where you just throw out a random number and then work it through the problem to see if it would work. A lot of times people guess 12 right off the bat, just because when you're making cookies, you lay out cookies on a cookie sheet. A lot of times you have a dozen cookies on the cookie sheet, right? So a lot of times people will just guess 12 right off the bat to begin with. But let's just show you how this would work if you didn't choose 12. Let's say that for some reason you were thinking 24, right? So to kind of go along with this first wrong solution that we talked about. So let's say that you guessed that 24 is the correct answer. So let's try 24. So reading through the problem again, it says Becky was hungry because she didn't have breakfast, so she ate half of the cookies, right? So 24 divided by 2. Half of 24 is 12, okay? Then Jill came along and noticed the cookies. She thought they looked good, so she ate a third of what was left in the jar. Well, notice that if Becky ate half of the cookies, then so if you're starting with 24, right? So this is all based on the guess. Maybe I should write down that our guess here is 24. So based on the guess that there were 24 in the cookies, 24 cookies in the jar initially, based on that guess, then Becky ate 12 of them. And maybe it would be worthwhile to see like how many have been eaten and how many have been eaten and how many are left. So when Becky came along, she ate 12 and left 12. Again, this is based on our guess of 24 cookies. Okay. So then Jill came along, and it says she ate a third of what was left. So there were 12 cookies left. A third of 12 divided by 3 is 4, right? So we're assuming then that Jill ate 4 cookies. So now how many are left? 12 minus 4 is 8, right? So there are 8 cookies left in the jar now that Jill has done her eating. Then it says Denise came by and decided to take a fourth of the remaining cookies. So there are 8 cookies left. So this is Denise now. Denise is going to eat a fourth of what remains. So 1/4 of 8, right? 8 divided by 4 is 2. So she's going to eat 2 cookies. 8 minus 2 is 6. So there are 6 cookies left. And then Jody came dashing up and took a cookie to munch on. So Jody is going to eat 1 cookie. And that would mean there are 5 cookies left. And this is where you notice a problem because Megan comes along and notices that there are 2 cookies left. So this number needs to be 2, but it's 5, right? So 24 doesn't work. So you know that 24 is not going to work, right? So then maybe you make another guess. Well, you make another guess and you say 12, right? So you say 12. So Becky's going to eat half of them, so that means she's going to eat 6, which means there are going to be 6 cookies left. Jill eats a third of what's left. A third of 6 is 2. So 6 minus 2 is 4, so there are 4 cookies left now. Denise comes along and eats a fourth of what's left. A fourth of 4 is 1, that means there are 3 left. And then Jody comes by, eats a cookie, that means there are 2 cookies left, and there you go, right? That's the correct answer, right? Megan. So when Megan comes along, there need to be 2 cookies left. And there were when we guessed 12, and so that means that 12 must have been the number of cookies in the jar. Now, let me explain where students get the answer of 72 from sometimes. So sometimes students do a guess and check type of thing like this, and they get 72. But here's why. It's because they're conflating the number of cookies that were eaten versus the number of cookies that were left over. Right? They're confusing those 2 categories when they get 72. So here's how you could do a guess and check incorrectly, right? So a lot of times students would say, well, so let's start with the guess of 24, for example. So they might start with 24 and say 24 divided by 2 is 12. Okay, and then they say 12 divided by 3 is 4. Right, so far so good. But now what they're thinking is that this is the number of cookies that were left, this is the number of cookies that are left, and that's wrong. This isn't the number of cookies that were left, this is the number of cookies that were eaten. Okay? So the number of cookies that were left would be 12 minus 4, right? Just like we did up here, right, with 8. originally. But a lot of times students will confuse that. They'll say, this is the number of cookies that are left. It's not. That's the number of cookies that she ate. But if they continue on with their incorrect thinking that this is the number of cookies that are left, then when Denise comes along to eat a fourth of them, they say 4 divided by 4, right? But 1/4 of 4 is 1. And now they're thinking there's only 1 cookie in the jar left when Jody comes by and snatches her cookie. And that leaves 0 cookies when Megan comes along to notice the number of cookies in the jar. And so they're thinking, 24 is too small. We need to go bigger. All right? And so they work their way up to 72. And then they say, okay, 72 divided by 2 is 36. 36 divided by 3 is 12. 12 divided by 4 is 3. And then Denise comes along and eats a cookie, and that leaves 2 left. Or sorry, Jody comes along and eats a cookie, and that leaves 2 left over when Megan comes along to observe that there are 2 cookies in the jar. And so they say, okay, so it should have been 72. But again, the reason they're getting 72 is because they're conflating the number of cookies that were eaten versus the number of cookies that are still left in the jar, right? So don't make that mistake. That's why making a table like this can really come in handy. So you're keeping track not only of the number of cookies that the person ate, but the number of cookies left over in the jar as well. So there's guess and check. Here's another way you could do it. You could do this with algebra. So with algebra, you could just say, let x be the number of cookies at the beginning of the problem, right? Excuse me. Sorry, I hope I didn't just break your speakers. Anyway, so let x be the number of cookies in the jar at the beginning of the problem. What we know is that when Megan, at the very end of the problem, when Megan comes along, we know that there should be 2 cookies left. So what I'm thinking is, if I can come up with an algebraic expression for the number of cookies left in the jar when Megan comes along, that should be equal to 2, right? That should be equal to 2. And if I can set up that expression, then I can solve for x, right? So let x be the number of cookies in the jar at the beginning of the problem, before anybody comes along to eat the cookies, right? And what I want to do is I want to get an expression for the number of cookies. So we'll say the number of cookies remaining. Okay, number of cookies remaining. Okay, so before anybody takes any cookies, there are x cookies remaining, of course. But then, Becky comes along and eats half the cookies. If she eats half the cookies, that means half of the cookies are still remaining. Okay, so that's after Becky. Then Jill comes along and she eats a third of what's left in the jar. Well, this is what's left in the jar when Jill comes along. So a third of that is how much she eats. But now be careful. Don't just write a third, because we're trying to keep track of the number of cookies remaining, not the number of cookies eaten. Okay? So Jill ate a third of what was left. That means the number of cookies remaining should be 2/3 of this, right? If she eats a third, then she leaves 2/3, right? So the number of cookies remaining in the jar is 2/3 of this number. Okay. Then what? Denise comes by. She eats a fourth of what's left. So this is what's left. Denise is going to eat 1/4 of that. That means she's going to leave 3/4 of it, right? So the number of cookies remaining should be 3/4 of this stuff. Okay? And then finally, Jody comes along and she eats a cookie. So if this is the number of cookies in the jar before Jody gets there, then after Jody's done with the cookie jar, there's that number of cookies minus 1 because she ate a cookie. Okay? And then finally, Megan comes along and notices that there are 2 cookies left in the jar. And so there you go, right? You've got this equation, which maybe looks a little bit nasty in its current form, but we can simplify it quite a bit, right? The 2's will cancel, the 3's will cancel. I guess this is just 1/4 x minus 1 equals 2. That means that 1/4 x equals 3, right? If you add 1 to the other side, you get 1/4 x equals 3. And then if you multiply by 4, then you get x equals 12. Right? And there you go. Again, students will often get 72 when they're trying to do the algebra, because again, it's because they've lost track of what they're counting up here, right? So they start to do this. They start off the same way we did. There are X cookies in the jar, and then Becky eats half of them, and then Jill comes along and eats a third, and so they write a third, and then Denise comes along and eats a fourth, and so they write a fourth, and then Jill comes along and eats one, so they subtract one, and then Megan notices that there are 2 left over, and so they get this equation, right? But it's wrong, because if whoever it was, Jill, Denise, I can't remember, Jill, I think, if Jill eats a third of the cookies, then that means she leaves 2/3 of them, so there are 2/3 cookies remaining in the jar. But this is just a common mistake people make. And so if you solve this one, you get 4 times 3 is 12 times 2 is 24. So they get 1/24 x minus 1 equals 2. So 1/24 x equals 3. And then they multiply by 24 and they get 72. Right? But this is incorrect. You could keep track of the total number of cookies eaten, but then the problem with that is you don't know what that number is equal to, because you only have information at the end of the problem about the number of cookies left in the jar. So that approach probably isn't going to get you very far. I think the best way to do it kind of algebraically is to think about it in terms of how many cookies are remaining in the jar, which is what we did here. Okay. Let me give you one more way that students sometimes do this problem. So another way that you could do this is you could work backwards. So working backwards. So working backwards. So you can start at the end of the problem and sort of try to piece things backwards, right? And so here's how this works, right? At the end of the problem, Megan notices that there are 2 cookies in the jar. So this is what this is what's remaining. This is what's remaining with Megan. Okay. Now, just before Megan got there, Jody had come along and had taken 1 cookie. So that means when Jody got there, there were 3 cookies in the jar. So we'll say before, this is before Jody took 1. Okay. And then before that happened, we had Denise, who had come by, and she had decided to take 1/4 of the remaining cookies with her to her next class. So to figure out what number goes here, you kind of have to ask yourself, you kind of have to ask yourself 3/4, right? If Denise is going to take 1/4 of the cookies, that means she's going to leave 3/4 of them. So 3/4 of what number is equal to 3? That's sort of like what you're asking yourself. So we could say, this is whatever number this is. This is the number that we get before Denise took 1/4, right? And so we ask ourselves, 3/4. This is the number that she left, right? 3/4 of what number is 3? You could set up like an algebraic equation to solve it. You could say 3/4 times x equals 3, and then solve for x. Or you could just kind of think through it. You could say 3/4 of what number is 3? Well, it should be 4, right? It should be 4. Okay? In other words, like if you imagine Well, that kind of requires you to already know that there are 4. Oh, here's what you could do. You could say there's some number of cookies, and we know that we're going to be left with 3, but 3/4 of what is 3/4 of what number is equal to 3? Well, obviously, if you add another portion on here, 3/4 of this number is going to be 3. And what's this number? It's 4, right? So there you go, right? Anyway, so 4. And but before Denise got there, Jill had come by, and Jill had taken 1/3 of what was left. So whatever this number is, this is what we get before Jill takes her 1/3. So before Jill took 1/3. Well, if Jill took 1/3 of the cookies, that means she left 2/3 of them. So 4 is 2/3 of some number. So we should be thinking 2/3 of what is 4, right? That's the number that has to go here. So 2/3 of what is 4? So I've got my 4 cookies, and that has to be 2/3 of some original number. So obviously, if I think of this as 1/3, 2/3, then 3/3 would be another set of 2, right? So now that's 3/3 to make one whole. So how many cookies are there? 1, 2, 3, 4, 5, 6, right? So 6. Or you could set up an algebraic equation. You could say 2/3 times x equals 4, and then solve for x, right? But there should be 6 when Jill comes along. Okay, but before Jill got there, Becky had already eaten half. So whatever number goes here, this is before Becky took half of the cookies. So that means half of whatever number is 6. Well, half of 12 is 6. Okay, and that's another way that you can get 12. Okay, by working backwards. Okay, so we talked about working backwards. We talked about setting up an algebraic equation. We talked about guess and check. We talked about drawing pictures, right? So there are 4 different ways that you could approach the problem. So I hope that helps with that. Usually in class this is a lot more fun, because usually in class we would take like almost the entire day just talking about this problem. I would let you talk about it in your groups, and then we would have like group presentations about how they solved the problem and all of that stuff, and it's a lot of fun. It's much more difficult to do that in a distance learning environment, but nevertheless, hopefully you still get some use out of what I've told you here. So that's that one.